All right, my friends, just to make sure everybody has an idea as to exactly what the distance formula is for and where it came from, let's just show a really quick, fairly simplified derivation. So if you've got these two endpoints, x1, y1 and x2, y2, I hope it makes sense, first of all, that the distance from the x-axis over to this first point, that would be considered x1. And then similarly, the distance from the x-axis all the way over to be even with the second point, that would be x2. So if I was to say start drawing a little right triangle, this length of this leg of the triangle would simply be x2 take away x1. And then similarly, what would the length of this leg of this right triangle be? You could go through and decide that the distance from the y-axis up to that first point would be y1. The distance from the y-axis all the way up to be even with the second point would be, where should I write that? I'll just say, I'll just show the whole thing. That would be y2. And so the distance of that, the length of that shorter leg there of the triangle would be y2 minus y1. There we go. And you've got a little, right angle there. And so what would Pythagorean theorem say about the relationship between the lengths of this triangle? Well, it would say the length of the hypotenuse squared, or d squared, would be the length of one of the legs squared plus the length of the other leg squared. There we go. And then you could just solve for d by square rooting both sides. We don't worry about plus or minus because distance is inherently positive. So no reason to bring on unnecessary negativity here. Oops. Let's see if we copy it correctly. Doesn't it? Oh boy, must be really in love with twos today. Anyway, there you go. And this is the distance formula. And, as demonstrated by its own derivation, you could get away with not knowing it, but it is going to be something really handy to have when we start talking about vectors and their magnitude and stuff like that. So anyway, so put that one in your back pocket if it wasn't already there. All right, my friends, let's move on. Let's start talking about some vectors. So the first thing that I want you to be clear on is some vocabulary that we'll be using in this lesson. So first, what is a vector? Please write this down. A vector is an object that has both a magnitude and a direction. Geometrically, we can picture a vector as a directed line segment whose magnitude is the length of the vector, and there's an arrow indicating the direction of the vector. The direction of the vector is from its initial point or tail to its terminal point or head. All right, my friends, if you need to, pause the video so you can get that written down. And then we'll switch to example 1, okay? So for example 1, oh, sorry for the weird line there. Pretend that isn't there. Anyway, so given point A with coordinates 2, 4, and point B with coordinates 5, 8, for part A, I'd like for you to graph the vector AB, and I want to emphasize the symbol. It's kind of here. It's typeset, so it's not very exaggerated. When you handwrite it, it's like the segment symbol, but with a little extra half arrow tip on the end there. So see if you can figure out, based on the definition that we just showed you, how to graph vector AB. And then from there, same thing, see if you can figure out how to use the definition to evaluate. We exaggerate the notation that we're using there for the vector symbol. Evaluate the magnitude of vector AB, okay? So these symbols right here, magnitude of vector AB, which I have a friend, Kenny, I met him when I was in grad school. Actually, before I tell you the story, I should write this correctly. Vector AB. There we go. Okay. Anyway, when he found out that I was from a town called Battleground, he told me I wasn't allowed to just say Battleground. I had to say it like I was like a World Wrestling Federation announcer, like Battleground. And then he would never say the word magnitude. He would always say magnitude. Anyway, so I try to say it normally, but in my head, I can hear the Kenny version. Anyway. So go ahead and see if you can figure out what to do with example 1, and then I'll go through it with you in the next video and see if you're doing great.